Picture this. You've just bought a shiny, state-of-the-art electric vehicle.
Oh, yeah. The absolute dream.
Exactly. I mean, the paint is flawless, the dashboard looks like a literal spaceship, and you are ready to just, you know, glide silently into the future.
Right. Or maybe you're operating on a much larger scale. Like you're managing a fleet of electric school buses for a massive district trying to get hundreds of kids to class with zero emissions.
It all sounds like this perfect utopian future we've been promised for years, but then physical reality hits. There's a massive bottleneck.
Oh, a huge one.
Right, like what do you do if the local power grid simply isn't ready for you? What if the utility company tells you it's going to take 3 years to upgrade the transformers and dig the trenches just to bring enough power to your parking lot?
Yeah, and looking just a little further down the road, what if your brand new vehicle is fully autonomous?
Oh, wow, right.
Like it pulls up to a charger without a human driver inside to actually physically plug that heavy cable in. What then?
It's a huge problem. Okay, let's unpack this. Because today, our mission in this deep dive is to synthesize a really fascinating stack of recent sources to figure this out.
Yeah, we are looking at corporate press releases from 2024 through early 2026, plus an investigative journalism piece, and this incredibly dense academic protocol paper.
And our goal here is to help you, the listener, understand the messy, paradoxical, and highly innovative bridge between our current infrastructure and that fully automated, electrified future.
Because it is the classic chicken and egg problem of any massive technological revolution.
Yeah.
We have the vehicles of tomorrow rolling off the assembly lines today, but, well, we are trying to operate them on the infrastructure of yesterday.
It's wild. And the friction between those two realities is creating some of the most bizarre, totally counterintuitive innovations we have ever seen in the transportation sector.
Absolutely.
So we're finding out why getting to a zero-emission future currently requires burning diesel fuel, and why plugging in a car now requires the same technology used to dock spacecraft at the International Space Station.
It really is wild when you lay it all out like that.
Let's start with the immediate physical roadblock we are facing right now, the electrical grid itself.
Right. So everyone wants to transition to EVs, but the transition isn't just about manufacturing the cars or the batteries. At its core, it's a logistics problem.
How do you mean?
Well, it is about moving unimaginable amounts of electricity to highly specific physical locations. And, utility companies move at the speed of, well, utility companies.
Glacial.
Exactly. Upgrading a local grid to handle a depot of, say, 200 electric school buses involves new substations, permitting, digging up city streets, waiting on back-ordered copper wire. That process can take literally years.
But schools, delivery fleets, airport shuttles, they can't wait years. They have emission mandates to meet today.
Exactly. Because fleets can't wait, an entirely new industry of off-grid mobile charging has just exploded. If the grid can't come to the vehicles, the chargers have to become mobile.
Like Pioneer Power Solutions, right? I was reading about them in the press releases.
Yeah, Pioneer is a huge player here. Back in mid-2024, they secured a $7.1 million order for 25 of their e-Boost mobile units.
Just to charge 200 electric school buses for one major U.S. district. That's crazy.
And demand is just skyrocketing. By early 2026, they're taking orders from a massive Canadian aviation hub, a Central Florida school district, and even a southeastern utility company.
That is so ironic. The utility company itself is buying mobile charger.
Right, and they aren't the only ones. Spark Charge is another fascinating example. They make a mobile battery trailer.
Which is exactly what it sounds like, right?
Yeah, it's essentially a towable unit that delivers up to 125 kilowatts of DC fast charging. It requires absolutely zero fixed infrastructure. You could lease it, rent it out for special events, or just drag it out to remote construction sites.
So it's basically like carrying a giant, towable smartphone power bank for a fleet of cars.
That is exactly what it is. And then you have companies like L-Charge taking a slightly different angle.
What are they doing?
They built a mobile EV charging and roadside assistance vehicle. So instead of a trailer you have to tow, it's a traditional service truck with a 60-kilowatt fast charger seamlessly integrated right into the body.
Oh, so you don't even need a commercial driver's license or anything to tow a massive trailer.
Nope. You just pull up next to a dead EV, like a roadside assistance truck, and start charging.
Okay, this is super cool, but I have to push back here for a second.
Sure, go ahead.
You can't just create electricity out of thin air. If the local grid isn't providing the power, where exactly is the electricity inside these giant mobile power banks actually coming from?
And that is the multi-million-dollar question. It reveals the massive underlying paradox of this entire transition.
All right, because I was looking at this and thinking, wait a minute.
Yeah, well, spark charge, as the name implies, relies on massive batteries. Those batteries still have to be driven somewhere with grid capacity, charged up, and then driven back to the site. But Pioneer,
Oh, this is the part that blew my mind.
yeah. To meet soaring market demand in 2026, Pioneer introduced the eBoost D-Mobile. The D stands for diesel, or renewable diesel.
Wait, you're telling me we are actively burning diesel fuel to charge electric school buses?
Yes, it is literally a mobile generator burning liquid fuel to create electricity, which is then pumped into electric vehicles.
That is, I mean, it's like eating a triple bacon cheeseburger and washing it down with a Diet Coke.
It is deeply ironic, but yes, that's reality right now. And L-Charge uses a similar concept, but through something called a power takeoff system, or PTO.
How does that work?
They use the service truck's own internal combustion engine to spin a heavy-duty alternator. The truck just sits there, idling its gas or diesel engine, generating enough electricity to provide 15 hours of continuous fast charging.
Just idling a gas engine to charge an EV? Incredible.
Even NASCAR got in on this. In
And
a recent event, they utilized renewable propane fuel generators to power off-grid charging equipment for EVs.
NASCAR.
If we connect this to the bigger picture, we have to acknowledge a very uncomfortable reality. The clean energy transition currently requires fossil fuels just to get off the ground.
Because the infrastructure gap is so incredibly wide that we are using combustion engines as a temporary bridge to cross it.
Exactly. And because propane and diesel are literally powering the EV transition off-grid, it perfectly explains why fossil fuel industries are fighting so hard to rebrand themselves as part of the clean future.
Okay, yes, the rebranding. Let's get into this because this Guardian article is fascinating. But really quickly, before we dive into this, I need to say this to you, the listener.
Yes, very important point here.
When we discuss this political marketing and the lobbying, both of us are remaining strictly impartial. We are not taking sides. We are not endorsing the fossil fuel industry, and we are not endorsing their critics.
Right. We are simply reporting the data and the marketing strategies exactly as they are detailed in the source material. Nothing more.
Exactly. So keeping that in mind, the marketing strategy unfolding here is massive.
It really is. The Guardian piece focuses on the Propane Education and Research Council, or PERC. They are a major lobbying group for the U.S. propane industry.
And their ad spend is just staggering.
Yeah, over a 2-year period, they increased their advertising spending 17-fold. They went from spending about $1.7 million on ads to nearly $30 million.
Almost $30 million. That buys a lot of screen time. And they are targeting climate-conscious millennials and Gen Z across platforms like YouTube, even YouTube Kids, all the way to Fox News and Southern Living magazine.
Right. They are blanketing the media. And the core message of this campaign is to completely redefine propane. They don't want you to think of it as a traditional fuel anymore.
No, they are aggressively marketing it as clean energy or renewable energy.
And it works. According to a PRC survey of 1,000 U.S. adults, an astonishing 97% of respondents did not consider propane to be a fossil fuel.
97%. That is a marketer's absolute dream, to convince almost the entire population that your product isn't what it actually is.
Yeah, but let's look at the reality check provided by the EPA and the U.S. Energy Information Administration. By strict definition, propane is a fossil gas.
Right. It's mostly a byproduct of refining crude oil or processing natural gas.
Exactly. The regulatory data points out that only a minuscule fraction, specifically 0.04% of the entire U.S. propane supply, actually comes from non-fossil sources.
But the industry talks heavily about renewable propane, right? Made from things like the camelina plant.
They do, but environmental scientists point out that camelina is basically a cover crop. Producing it at a scale large enough to replace fossil propane is, at this stage, largely theoretical.
But even if we ignore the scale issue for a moment, let's say they do figure out how to mass-produce plant-based renewable propane, doesn't burning it still release carbon?
Yes, when you combust a carbon-based molecule, you release carbon dioxide.
Right, so how can it be clean energy? It's still smoke going into the sky.
The industry's main talking point is a game of relativity. Renewable propane emits less carbon than burning coal and less than burning diesel.
Okay, fair enough.
But it still emits more carbon than burning natural gas.
Right.
So it is absolutely not a zero-emission power source like a wind turbine or a solar panel.
But going back to our first point, because the electric grid is lagging so far behind, these fuels are stepping into the void.
Yes, and that physical reality gives them a very powerful, highly visible narrative to claim they are indispensable to the clean energy transition.
Okay, so we've solved where the power comes from, even if it's a very messy, highly engineered bridge. But let's look past the bridge for a minute.
Sure.
Let's imagine the grid finally gets upgraded, the power is flowing. As these vehicle fleets scale up, and especially as they become autonomous, we run headfirst into a completely different kind of bottleneck.
Ah, yes. The human bottleneck.
Exactly. If there is no driver who physically takes the heavy, thick charging cable and plugs it into the vehicle.
This is a huge issue because we are rapidly entering the era of the robotaxi. Companies like Waymo and Zoox are operating fully driverless vehicles right now.
Tesla is gearing up with the Cybercab, too.
Right. And current charging protocols like ISO 15118, they have a massive blind spot. They all assume a human being is standing there to physically insert the plug.
So the software literally waits to detect the mechanical click of the plug locking into place before it even starts the digital handshake.
Exactly. No human, no click, no charge.
So how do we fix that?
Enter the academic paper we reviewed on ACAPF, the Autonomous Charging Alignment Protocol. It is a highly complex four-phase software and hardware protocol designed to take a driverless car, navigate it into a spot, and plug it in without a single human finger.
4 phases, right. Discovery and reservation, approach and alignment, connection and charging, and departure and settlement.
Yes, and the goal is to get the total overhead from pulling in to charging down to under 45 seconds.
Okay, I have to question this. Getting a robot to align and plug in a car in under 45 seconds sounds great on paper, but these robotaxis already navigate complex city streets flawlessly.
They do.
They dodge pedestrians, they read signs, they use cameras and lasers. If they can do all that, why do they need a dense, entirely new academic protocol just to park next to a charger?
What's fascinating here is the extreme physical precision required. Navigating a street requires accuracy down to maybe a few inches, but inserting a high-voltage charging pin into a socket using an automated robotic arm.
Let me guess. Millimeters.
Exactly. Millimeter tolerances. If a robotic arm misjudges the angle by a fraction of an inch, it will crush the vehicle's charge port. That's thousands of dollars in damage. Or a severe high-voltage fire risk.
Oh, man. It's like the frustration of trying to plug a USB cable into the back of your computer in the dark, but if you miss, the computer catches on fire.
That is a very accurate and terrifying way to look at it. So to prevent that, ACAP uses the three-stage docking funnel. It is actually similar to the protocol used for spacecraft rendezvous in the International Space Station.
Spacecraft technology for a parking lot. I love it. Walk me through the stages.
Stage A is the coarse approach. It uses a standard 5G or cellular signal to guide the vehicle to the general entrance of the charging bay, getting it within 1 to 3 meters.
Which is basically just pulling into the driveway. Pretty standard.
Right. Then stage B is precision guidance. 5G isn't accurate enough here, so it switches to ultra-wideband, or UWB, radio signals.
Okay, how does that work?
UWB sends billions of pulses across a wide spectrum of frequencies and measures the exact time it takes for them to bounce back. This gets the car parked to within 5 to 10 centimeters of the perfect target pose.
5 to 10 centimeters. That's close, but still not enough to plug it in safely without crushing something.
Right, which brings us to stage C, fine docking. The car is stationary, and the charger itself takes over using structured light and vision sensors.
Like Face ID on a phone.
Exactly like Face ID. It maps the vehicle's charge port with 1 to 5 millimeter precision, calculating the exact 3D angle to guide the robotic arm in.
That is unbelievable engineering. But AC Key is just the software making this possible. What does the hardware look like in the real world?
Well, we have a fantastic example from a partnership between Beam Global and a company called HEVO. They created a market-ready autonomous wireless charging platform.
This was the one that blew my mind in the notes, because Beam's product, the EV-ARC, is entirely off-grid.
Yes, it is a 100% solar-powered canopy that fits inside a single standard parking space. It requires zero construction, zero utility connection. You just drop it in a parking lot.
And it can withstand 160-mile-per-hour winds and 9.5-foot floods. That is tank-level durability.
Absolutely. And then you integrate HEVO into the mix. They provide the wireless charging pad on the ground, so an autonomous vehicle just drives itself under the solar canopy, parks over the pad, and it charges wirelessly.
No grid connection, no humans, and no robotic arms required.
None at all.
Yeah.
But entirely removing the human from the equation introduces a terrifying new variable.
Right. Cybersecurity. Because with no humans around to verify the station, how do you protect the cars from hackers?
It's a huge problem. The ACPIP paper highlights some terrifying vulnerabilities when machines are left alone to talk to machines.
Like the broken wire attack.
Yeah. A hacker with a cheap radio can completely disrupt a charging session from almost 50 meters away. Or worse, a remote attack called deception, where a hacker tricks the charger into blasting the car with overcharging currents.
Which could instantly destroy the battery or start a massive fire.
Exactly. If a robotaxi pulls into a random dark parking lot, how does it actually know the charging pad isn't a rogue station set up by a hacker?
Here's where it gets really interesting. The ACAP protocol solves this digital trust issue using something called cryptographic spatial anchors, or CSA.
Yes. To defeat GPS spoofing and remote relay attacks, ACAP forces the car and the charger to mathematically prove they are physically touching each other.
Okay, explain how they do that.
Both the vehicle and the charger contain military-grade security chips called TPM 2.0 modules. During that ultra-wideband docking phase, they use radio timing to measure the exact distance between them.
Right, because radio waves travel at the absolute speed of light. You can't fake that timing?
Exactly. If a hacker is sitting in a van 50 feet away trying to intercept the signal, the extra time it takes for the signal to travel to the van and back creates a microscopic delay.
And that delay instantly exposes them.
You nailed it. They verify they are within exactly 15 centimeters of each other, and then both of their TPM chips cryptographically sign a document swearing to that physical distance.
It's an unbreakable physical handshake.
Only after that is verified does the power start flowing and the digital fleet tokens are exchanged to pay for the energy.
It is so wild to think about. Okay, so let's wrap this up. We've covered a lot of ground today.
We really have.
For you listening, the big takeaway here is that the transition to a clean, automated future isn't a neat, straight line.
Not at all. It involves bridging the massive infrastructure gap with diesel-powered mobile chargers, navigating aggressive fossil fuel rebranding, and engineering literal spacecraft-level docking protocols just to safely charge a battery.
Which brings us to a final thought I want to leave you with. If our vehicles become completely autonomous, finding their own solar pads in the dead of night, executing complex cryptographic handshakes to prevent hacking, and paying for their own energy with digital fleet tokens, what happens to the traditional gas station?
That is a great question.
Right. Today, they are built entirely around human needs. Bright lights, snacks, bathrooms. But will those human-centric rest stops disappear entirely? Will they just be replaced by invisible machine-to-machine charging hubs hidden in plain sight?
It totally redefines the landscape.
It really does. So the next time you drive past a brightly lit gas station, just look at it and imagine how it will physically transform when the machines take over their own maintenance.